Hello everyone, and welcome to this machine learning techniques course of the online BSc in programming and data science program. My name is Arun Rajkumar and I would be the instructor for this course. So what we are going to do now is start with a very high level introduction to what machine learning is. Of course, if you had taken a previous prerequisite course, which is the machine learning foundations course, you would have a fair enough idea of what machine learning is, what kind of problems are being solved using machine learning. Nevertheless, to keep this course a little bit self-contained, what I thought was I'll just go through, a very high-level introduction, try and give a flavor for what is going to be covered in this course, what types of problems we will try to solve, and things like that. Okay, so we'll get started. The first question we'll ask is why are you trying to take this course, and what is the reason, right? There could be several reasons, but one of the very compelling reasons is that there are several applications of what you might see in this course, right? So, for example, the top 10 digital transformation trends as listed by Forbes magazine a couple of years back listed a couple of things which are highlighted here in red, including analytics, AI and machine learning, conversational AI, autonomous drones, and so on. All of these things depend on one way or the other machine learning algorithms. As you can see, machine learning is in some sense fundamental to several applications, practical applications, and you will see many more applications as we go along in this course. So that is the why part. So now you can also ask, well, how popular is machine learning? I don't have to really answer that question if you've been following the technical digital trends and things like that. Nevertheless, what I did was I did today search for the term machine learning on Google Trends, and then I also added, I'm also showing you the trends for the word search for the keyword deep learning and for the keyword artificial intelligence. The one in machine learning is in blue, deep learning is in red, and artificial intelligence is in yellow. And as you can see, in the last couple of years, let's say from 2016 onwards, there has been a boom in these in these keyword searches, right? So just indicating the amount of popularity and the amount of applications that algorithms and machine learning have had an impact on, right? So of course, deep learning is a subset of machine learning, which will also be covered in one of the elective courses in this program. Artificial intelligence was, originally the idea of making a computer trying to, in some sense, mimic a human. So you would see a lot of artificial intelligence-based searches in the early 2000s and so on, as the yellow curve indicates here. But then as machine learning kind of took over, so the broader term artificial intelligence had gained lesser and lesser popularity. But now recently, with more recent advent of several new ideas in artificial intelligence, including causality and things like that, so that also has seemed to picked up a lot. Okay, so now let's ask the question, well, where can we apply machine learning algorithms? So for this, I would like to imagine a prototypical human being, and the type of activities a human being does. If you really want machines to learn and mimic humans, we should first understand what are the things that come naturally to humans and see how we can make a machine mimic these, right? So for this, one of the main or one of the major areas where machine learning is applied is in vision, what is called as a computer vision, which just tries to understand how you can make a computer see, right? So how can you provide the ability of vision to a computer, if you will, which means to understand a very, very complicated organ like the eye, which has evolved over several millions of years, the human eye. Where it can take in information, process it using the brain, and then take decisions based on that, right? So now if you want to mimic that, so there are a lot of challenges, right? So for example, how does the human eye kind of look at a picture and then say, hey, this is a picture of a tree, right? So now if you want the computer to do that, to do things like object recognition, so now we need to develop algorithms which more or less try to mimic the human eye. So that's a broader area where you might see machine learning algorithms often being applied. Speech is another thing where speech is another in some sense an unstructured data where different people say the same thing in different ways, and yet we make, as humans, we make meaning out of this, right? So very easily, naturally, over time, we have learned to understand human speech. Now, how can we make a computer do the same, right? That would be learning to, understand natural language, for instance. That would be the speech part of it. Text is another important source of inputs. Documents, there are billions and billions of documents, I mean millions generated as we speak on the internet, and all of these are unstructured. Again, people write in different ways the same thing, but then, can we somehow understand the semantics of text, right? So from just written text, or it could be even simpler problem like can you look at a text and then look at the handwriting and then figure out what is being written in this, and so on, right? So there are a broad range of applications there as well. Of course, the holy grail is to crack the human brain. How does the brain work, right? So brain is such a complicated organ with millions and millions of neurons interconnected in complicated fashions, and then produces decisions. How can we understand that from a more abstract computational point of view, right? So that is, how can you learn like how our human brain learns? So that's another major area. Of course, the holy grail of machine learning. We are nowhere close to doing that, but then we are making slow, baby steps progresses. Of course, these are the human sensory applications, but then there are several others, right? So you can think of any experiment that generates a lot of data is amenable to analysis. In fact, you can learn and predict from data. So that's the whole idea of machine learning. Stock markets, financial sector is another major area where machine learning algorithms are typically used to predict whether a stock will go up or not. You have to see how the stock has performed over time and then make models and then use that to predict and so on. Experiments, again, biological experiments, chemistry experiments, and so many other, materials engineering, for instance, right? So there are applications, innumerable number of applications in science and engineering. Two other examples that I just want to highlight are one in sports, right? So sports analytics is a big area in itself, where you want to predict, which team would perhaps win the next IPL match. Would it be Chennai or would it be Bangalore, right? So of course, being a Chennai fan, I would say that perhaps Chennai would win, and maybe many of you might agree with that. Nevertheless, if you want to confirm that with a computer's prediction, well, you can take a lot of data and then run it using algorithms, and then it would give you a prediction as well. And finally, not finally, one other example to just give you a flavor is e-commerce. We all use e-commerce websites perhaps on a daily basis, your Amazons and Flipkarts and whatnot, where you purchase a lot of, you go there to purchase some product, and then immediately you get a recommendation saying that, hey, if you like this product, maybe you should buy this product as well, right? So which means that there is some machine learning algorithm under the hoods which is trying to figure out, well, this person is trying to buy this product, and there are these people who are similar to this person who have bought similar products, so why not recommend that product to this person, right? So there is this algorithm at the back which kind of predicts which is the product that should be shown to this person, which will perhaps maximize his chance of buying it, so that the company can, of course, make money. Okay, so these are some applications of machine learning. There are many more, and you can think of you can try to think of different applications not listed here by just observing your workplace or your areas of interest, right? So I'm sure there will be some application of machine learning whenever there is a lot of data involved. Okay, so now let's ask the question, what is machine learning, right? So we know why we are learning this topic, and we kind of have a high level view of where it is applied, but then we want to understand what it is, right? So the way I'm going to think about this is, first let me tell you what is not machine learning, and then we'll try to compare and contrast with what is machine learning, right? So what is not machine learning? Machine learning is not a procedural approach to doing things. For those who have a computer science background must be very used to an algorithmic way of thinking about things. You have a problem, you write an algorithm, and the algorithm solves the problem, right? So a simple example could be tax calculation. I give the input as my salary, my savings, and then there is a set of rules that you apply, and then out comes the tax that I need to pay. Right. So there is no learning happening here per se. So this is a procedure that you follow, which takes as input, does a series of steps in an algorithmic fashion, and out comes an output. Right. So there is nothing that is being learned here. It's just a procedure which maps an input to the output. That is not machine learning. Right. So there has to be a learning component, and we'll see what this learning component as we go along in this course. An important and perhaps the most important point about what is not machine learning is that machine learning is not memorization, right? To give an example, let's say we want to compute the, we want to perform the task of recognizing a tree in a picture, let's say, right? So now let's say you have 1,000 pictures of trees and 1,000 pictures of which does not contain a tree, right? So now you have 2,000 pictures. You can look at these 2,000 pictures, memorize which ones have trees and which ones do not have trees. Now, does that mean you have understood the concept of tree? What is, how do you, for instance, will you be able to predict whether a picture has a tree or not in a given picture which is not in these 2,000 pictures that have been shown to you? Perhaps not, because what you have done is just memorizing, and then if you're shown a picture which is already there at the set from which you have memorized, perhaps you would be able to answer well, right? So on the other hand, if you're shown something which has a tree but then was never a part of your data that was shown to you, well, unless you understood what it means to be a tree, what does it mean for a picture to contain a tree, you would not really be able to answer that question, right? So it's another example. Think of it as if you're being taught a lot of things in this course and you solve all your assignment problems, and if your final exam is going to just test you only on the problems that you solved during your assignments, then of course it's not going to be too hard, right? So you can simply memorize all the steps for all the problems in the assignment, and then you would score the highest amount of marks. But that does not mean necessarily that you have learned the subject, right? So this memorization does not imply you have learning. That's the point I'm trying to push here. We'll see what it actually then means to learn in a minute. Of course, another popular misconception is that, well, we see machine learning as a buzzword that has been thrown around in different contexts all around the place. Artificial intelligence, deep learning, machine learning, you keep hearing these buzzwords. It feels like magic, right? So there are so many things that these complicated algorithms have achieved today that it feels like magic, whereas of course it is not. But then if it is not magic, what is it? So let's try to go over these 3 points and then try to actually see what they mean in a machine learning context. Well, if machine learning is not procedural, then what it is? What is it, right? So there is a secret sauce which does not make it procedural, and what is that? Well, that is data, right? So all your machine learning algorithms are going to work on some data. It is going to learn from this data and then use this learning to make predictions or whatever the task that you want to solve on a test data, right? So the secret sauce for machine learning is data. So it is of course algorithmic, right? So we are going to see algorithms and so on, but then how does it differentiate from a standard computer science algorithm is that there is this extra bit which is the data. We'll see more about what does it mean to say you're learning from data and so on. I mean, that's the point of this course anyway. If it does not memorize, then what does it do? Well, we want machine learning algorithms to generalize, right? So that's the technical term that we use in the machine learning literature. What does it mean to generalize? Well, in layman's term, it means that you actually learn, not just memorize, so that you are able to predict well, you do well on an unseen data, right? So you are able to generalize your understanding from the data that you see to unseen data, right? So you are not like specific to the data that you have seen only, which would be easy to do, which you can simply memorize. Whereas if you don't want to be specific, you must be general enough. Well, when can you be general enough? When you've actually learned, right? So we want our algorithms to learn. We want our algorithms to generalize, to do well on unseen data. How do you do that? Well, that is what this course is about. Well, if it is not magic, what is it then? Well, it's basically math, right? So it just uses a lot of mathematical ideas, and we'll see some of the prerequisites. Of course, if you have taken a machine learning foundations course in this in the online BSc course, you would already know what these prerequisites are. I'm anyway going to cover them, but then these are basically mathematical ideas that we need to do well in the machine learning. I mean, to understand and appreciate the machine learning algorithms well. Okay. So with that short introduction, let me give you some concrete examples of machine learning problems, and then we'll quickly try to understand what are the broader paradigms of machine learning. So here are some problems. So one of the problems, a very popular problem, is to predict whether a given email, or let's say even an SMS, is a spam email or a non-spam email, right? So basically your spam filters in your in your email inbox, most email providers have a spam filter, which means that automatically you don't do anything, automatically the email is tagged as spam or not, and then it automatically goes to a spam filter. Of course, it makes mistakes sometimes, but most of the times it gets it right, right? So how does this happen? Well, the spam filter itself is an algorithm which has had access to a lot of data, a lot of which are spam, a lot of which are not spam, from which it has learned to differentiate a spam email from a non-spam email, right? So that's an example. Forecasting rainfall. Well, you have data about how much did it rain in the last 15 years, let's say, and you want to forecast whether it will rain tomorrow or not. Of course, you might have a lot of other features associated with this. For instance, you might know the precipitation levels, the atmospheric pressure, humidity, whatnot, about every single day in the last 10 or 15 years that you have, and you have to use that to somehow figure out whether on this particular day, which is tomorrow, let's say, will it rain or not, even if you know these other parameters, let's say precipitation, air pressure, temperature, and so on. Can you forecast rainfall? Another example, recommending movies. Of course, if you use an OTT platform, let's say, and you log into it, you are going to be shown a list of movies, and then these might be categorized as new arrivals, whatnot, and so on. But then you might also see a topic which says that movies that you might like or recommended for you, right? So that is a set of movies which are very, very specific to you, as opposed to your friend who might also have the same account, who might have an account in the same OTT platform, but then might get a different set of recommendations, right? So which means that depending on what kind of movies you watch, what kind of genres you like, right? So you get a list of tailor-made suggestions for you. That might be one, again, machine learning application, right? Friend suggestions. So if you are in social media or even in a professional social network such as LinkedIn, let's say, right? So you might often see people you may know or people you may want to be friends with, kind of a list that gets automatically generated, right? So these are people who with whom you're not friends or connections a priori, but then the system suggests you these things, right? So which means there is an algorithm which uses a lot of data to figure out what kind of people are more likely to be friends, and then uses that to give you a list of suggestions, an ordered list of suggestions. As a slightly different example, you can look at voice/instrument separation. Let's say you have an MP3 of a beautiful song sung by a favorite singer, and for whatever reasons, you may want to, separate the voice, the singer's voice, from the instrument, right? So now how can you do this automatically, right? So there is some structure in how voice signals are, some structure in how instrument signals are, but then what you have in an MP3 is a combined effect of these two. But how can we actually separate these out? Let's say if I give you a lot of voice only MP3s, a lot of instrument only MP3s, you somehow can we learn how to separate voice from instrument in a different MP3 file which has both overlaid over each other. That might be a machine learning problem too. Grouping pictures in phone. Well, yeah, so you have your favorite smartphone where you take a lot of pictures, but then you don't tell who is in which picture, but the system automatically says, hey, these pictures, it looks like they all have the same person. Well, these pictures might have been taken in different angles, might have been taken in different backgrounds, different locations, different time of the day, right? So still, the algorithm in your smartphone is able to figure out that it looks like these pictures contain the same person. It may not know who that person is. That's why it's asking you to tag that person with a name, but then it knows by just looking at these face similarity that, well, all these seem to have the same person, right? So that might be a machine learning problem. It means that you need to figure out, using a lot of face data, how are faces related to each other, right? So I mean, what distinguishes one face from the other, right? So things like that. As a slightly more complicated example, you might want to think about things like robot navigation. Maybe there is a robot that's at one end of the room, and then the goal of the robot is to reach the other end, and then there's a lot of obstacles in between. Now from standard machine learning problem, this might be slightly different, because here the robot has to make a decision to move either forward, left, right, back, and then after it makes a decision, it's given some feedback, right? So, and meaning if it moves forward, maybe it goes and hits against a wall, and that's a feedback to the robot that, well, this is a wrong direction to move. But moving forward might be a good direction in a different place, right? So it's not like moving forward is always a bad decision to take. So it has to learn where to take which decision by making mistakes, right? So that's again a learning problem. It's learning by experience. So that's a standard example, or it's a little bit complicated example than the algorithms that we will see in this course. Nevertheless, a machine learning problem. Stock market prediction, as I said, well, you would want to predict whether a particular stock will go up or not on a day. Of course, you don't know that, so you make the prediction in the morning, and then the evening you observe how much did the stock go up or down, right? So based on that, maybe you change and then make a prediction for the next day, and then again only in the evening you get the feedback whether the stock went up or not. So over time, I mean, what is a good metric to say that, well, is your algorithm successful or not? Maybe how much money did you make, how many missed chances were there, and things like that. Nevertheless, the main point is you are trying to learn over time, right? So this is also a learning problem, right? So you may not learn in one shot, but then you may want to learn over time, right? So that's an example of stock market prediction problem. Okay. So these are some examples. Of course, you can think of, your own examples of where machine learning problem can be applied.